In this video, I'll show you how to make an obstacle avoiding robot using sonar. This video is titled Part 1 because it's a prototype mode, so it's fully functional, but it is not the prettiest. If you want me to make another version which is both functional and aesthetic, comment down below and I'll make an updated version. This is a slightly kind of different video because it involved a lot more improvisation and experimentation than usual. And originally this was actually supposed to be a line following robot, but the PCBs I ordered, they weren't the best quality, and the soldering tracks kept getting damaged by the heat. So then I thought that I could use the ideas from my other sonar video, which is linked in the card above, to make this, which is an object detecting and avoiding robot. So for this project you'll need an Arduino UNO, an L298N motor driver, or some kind of caster wheels, gear motors, a sonar module, a servo motor, and a bunch of jumper wires. So I've drawn up a quick schematic of the circuit and it looks a bit complicated, but it's really quite simple, so I'll talk you through it. So you want to start by connecting the 9-volt battery to our motor driver by connecting the positive wire to the 12-volt terminal and the negative wire to the ground terminal. We can also solder wires onto the gear motor and connect the positive wire to output 1 and the negative to output 2, and likewise for 3 and 4. It shouldn't matter which way around the positive and negative terminals go, and then you can also connect inputs 1, 2, 3 and 4 to pins 7, 6, 5 and 4 respectively. Next, let's look at the ultrasonic sonar unit. So we can connect VCC to the 5-volt pin of the Arduino and the ground pin to the ground pin in the Arduino to power it up, and then we can connect echo to pin 8 and trigger to pin 9, as you'll see is defined in the code later on as well. We also want to take a jumper wire and connect V in to the 12-volt terminal of the motor driver and ground to the ground terminal of the motor driver. Next, looking at the servo motor, you want to connect the red wire to IRF, you want to connect the brown wire to the ground pin of the Arduino, and you want to connect the orange signal wire to pin 10 of the Arduino. So you can see in the code here that we've defined what each of our pins are in this section. Here we've been able to set the motor pins as output. Here we've set the trigger pin as output to transmit the waves and the echo pin as the input to receive the waves from the ultrasonic sonar module. In this section we can give the instruction to transmit waves, and then here we can receive the reflected waves, and the Arduino can then figure out the distance of the object. Here we set the condition for if there is no obstacle we keep moving forward, and here we set the condition of if there is an obstacle then what do we do. So first we want to stop, move backwards, stop, and it will power one of the wheels to move left so it can move back around in a circle to circle away from the object. So fundamentally it's quite a simple code, and you'll find it linked down below in the description, and all you got to do is upload this to the Arduino and we should be good to go. So first I hot glued the sonar module to the servo motor in the same way that I did in the sonar video. Then I assembled the circuit as I showed, and what I'm going to do is I'm going to use a hollow box as the body of the car, and I'm going to cut a hole in the lid so I can pass the power wire through so the battery can sit inside the box. So anyway, you can test the wheels by connecting them to the output terminals like we showed in the circuit, and then by putting one end of a jumper wire in the 5-volt terminal and the other touching input 1, and that should make it start to spin, just so you know that it's working. So at first I was putting in 3 volts from the power supply, and what was happening was that the wheels were turning slowly and the servo motor wasn't moving quite how it should have been. So then I put in 6 volts from the power supply, which seemed to fix it, and just to be sure I was giving the right amount of voltage, and for the sake of convenience, I used a 9-volt battery in the final build. The version of the code that I'm going to show you is the final one that worked, and that's linked in the description down below. But it took a bit of tweaking because at first the forward propulsion was working, but the sonar module wasn't responding to the objects that were in front. When I finally got it to work, you can see that when I put my hand in front of the sonar module, it detects it and it instructs the servo motor to move to look for a free space that has no object in front of it, and it stops moving forward, and then when only one wheel moves, that means it can change direction and turn to move forward in a different direction. So next I took it to my little testing track and as you can see, this version only had one central caster wheel, which was a bit of a problem because it often got stuck going in circles, or when it tried to change directions it tipped over because it wasn't properly balanced. So then I was going back to the drawing board and I decided to put 2 caster wheels which were spaced on each side to give it more balance. And then going back to the track again, we can see that now it's able to stay balanced when it's trying to turn. But the thing is, because I used the hollow box of the body of the car, it meant that the whole assembly was too light for the wheels to be able to move it properly. So remember, this is just a prototype, and I came up with a very raw and a very pedestrian solution, which was to place 2 rocks at the back end of the car. And surprisingly, that actually seemed to work in weighing down the back. As you can see, it started to work functionally as we wanted it to. Now, it's not perfect because sometimes it does get stuck and sometimes it fails to recognize objects which were lower than the ultrasonic module, because those are basically its eyes in essence. So if an object's below the ultrasonic module, it can't see it. But as it is, I'm happy that it serves as a good proof of concept because it was able to successfully detect objects and change directions in response. If you want to see a functionally improved and a more aesthetic version, comment down below and I'll make an improved design. But that's it for this video. Thanks for watching, and I'll see you guys next time.